Hello students. So today we are going to learn our fifth chapter, circles. Here we are going to deal with the new concepts such as chord, equal chord, length of the chord and all. So what does a circle mean? Yes, as you all know, circle is the closed two-dimensional figure which has no opening. It has a center joining all points which is equidistant from that particular center. Isn't it? Yes. So as you all know, the main part of a circle are its center, radius, diameter and circumference. Yes. Beyond that, we are going to learn about chord, sector, segment, arc, etc. Okay. So here, first of all, let's discuss about chord. What is chord? Any guess? Yes. Chord is the line joining any two points on the circle that is joined by a straight line. So this is called a chord. See, here many chords are drawn inside a circle. All the lines are chords, isn't it? And some of them are diameters in some figures. So from this, how can you identify the equal chords? See, can you identify from that figure? The chord which are equidistant from the center are called the equal chords. I will show it with an video example. Okay, listen here. So here we are going to prove the theorem that equal chords of a circle are equidistant from the center. So here as you see there is a circle centered at O and two chords AB and CD are drawn. Given that these two chords AB and CD are equal and what we have to show is we have to prove they are equidistant from the center, that is OM equal to ON. So see, let's before that consider, let AB be a line and from a point P we are drawing a perpendicular, okay, to the line AB. We are drawing a perpendicular from P. What is the peculiarity of a perpendicular dropped to a line? What will be the what will happen there? Yes, exactly. The perpendicular will cut the line AB into equal halves, isn't it? So the perpendicular here is PM. So PM will cut the line segment AB into equal halves. Is that clear? So this condition we are using here, okay? Because as we consider the circle and two chords AB and CD, here ON and OM are perpendiculars dropped from the center O. Clear? So here the chord AB is cut by the perpendicular OM and the chord CD is cut by the perpendicular ON. Okay, how it is cutting? It is cutting into equal halves. Is that very clear? Yes. So how this OM and ON are being perpendicular? Yes, from the center, if you are dropping a line to the chord, then it will become a perpendicular line. Perpendicular line means 90 degree. So this is applicable for every line segments. Okay. So clearly we can say OM and ON are perpendiculars that cut the chord AB and CD into equal halves. So is that clear everyone? So here now we are going to construct two triangles by joining A to O and C to O. Okay, so we got two triangles OAM and OCN. It is given that AB and CD are equal chords. So we are going to write it AB and CD are equal chords, that is AB equal to CD, which is given condition because they are equal chords. Okay, so it it resembles that half of the AB equals half of CD, isn't it? So as I mentioned before, OM and ON are the perpendicular bisectors. It cut the chords into equal halves.